Welcome back. Here we are. Hello. And we're going to finish up with a couple more mechanisms. Here's the ketone we just liberated from its thioacetal protecting group. And this is aluminum hydride reagent. And I didn't show the lithium that goes with it because it's a spectator. And HCl will protonate the O. This is one of our simpler mechanisms. I think you like this one. Don't forget to make hydride first. This is the nucleophilic hydride, not the basic one. And I want to point out there's a new H here that you don't see, but you know it's there. Wasn't there before. And that will make an oxide, which will protonate in step 2. You cannot combine the protonation with this step. Protonation is a separate step. I need to see the result of 1 before you do 2. I am repeating myself on purpose because I don't want you throwing away a point for failing me to show the result of step 1 before step 2. And that's what you would lose, 1 point. CH2 once, twice, C with a methyl. It's got an O minus. It's got the new H. Sadly, it should be a blue H, but you don't even need to show me, do you? Here, let's leave it off. There's an H there. Didn't used to be there. There's this methyl here. Used to be there. O minus grabs H, and you are done with this mechanism. How many points do you get for this little mechanism? You get a point for this arrow, and you get a point for hydride attacking the carbonyl. You get a point for this intermediate. That's 3. And then the 4th point is to protonate the intermediate. 4-pointer. Let's pretend we knew that already. Down here, substantially more points. There's our ketone and a secondary amine. Aldehydes or ketones will react with secondary amines to make enamines. And I wasn't very specific with my instructions. Let's be a little more specific, because this one I want the mechanism for both products. Predict the major product and give a mechanism for both products. Both. Okay. So I'll do the predicting after I do my mechanism. There's no need to activate the carbonyl. I don't know if I mentioned this during the lecture when we studied enamines and imines. There's no need to activate the carbonyl because in this case, our nucleophile is more reactive than, say, water or an alcohol, which are both poor nucleophiles. So another way to overcome the problem of carbonyls being weak electrophiles is to use a stronger nucleophile. And we combined it before. So look on your lecture notes if you want to shorten this one a little bit. I won't shorten it here. First step is to attack and generate an O minus. Phenyl, CH2 once, CH2 twice. Carbon with a methyl and a nitrogen. Two methyls, and What do we got? We got an O minus. It looks like I don't have the other hydrogen on the nitrogen. Nitrogen now has 4 bonds. It's an ammonium ion. Okay. I have a base in the same molecule as an acid. Conjugate base of an alcohol. Alcohol's pKa's are typically 17, 18. An ammonium ion, typical pKa is 10. I'm going to go away from 10 towards 17. So you want to see how you can get partial credit? Here it is. Nope. Grab the H, put a lone pair on nitrogen. I'll tell you why you're only getting partial credit very soon. Nothing wrong with your arrows except for one thing. This O minus, as it reaches for the H, will form a transition state as it makes this bond of 1, 2, 3, 4 atoms. That will be a square. A square with a very tiny hydrogen in one of the corners. That's a very strained thing. It doesn't happen if this molecule has another option. And yes, the other option is to grab it from a second molecule. And you show me you know that by saying that arrow has to happen between different molecules. 2 identical molecules that look just like this. There. Done. And now I am going to kick off hydroxide. And you should be saying to yourself, kick off hydroxide. Hydroxide is a terrible leaving group. Why can this even happen? And once again, I'll bring up the point I brought earlier. The point earlier was, usually you have to activate a carbonyl. Why did we not have to in this case? Because this nucleophile is much stronger than a poor nucleophile. Why can I make a poor leaving group leave? Well, this lone pair is more reactive than normal lone pairs. In fact, you'll see even in the textbook, it says amines are, it says pushy. It's pushing its electrons here just like it pushed them here. And it kicks off a poor leaving group. Phenyl. CH2 once, twice, 3 times is a carbon that now has a double bond to nitrogen. That's an iminium, isn't it? It's not an imine, it's got a plus. It's an iminium. And we also made hydroxide. And we're supposed to account for 2 products. Here we go. Wish me luck. Use the hand. I think I'm slowly getting better with this new system here. I might just jinx myself saying stuff like that. All right, what do we got? We have to make this one. Let's make that one from this one here. It looks like this carbon up here has 1 H. The same carbon here, 2 away from the phenyl, has 2 H's. One of those H's has to go. And you know what an appropriate name for an H, 1 away from the iminium could be. It's alpha. So this is going to grab the H, make this pi, and neutralize. Let's show it. Grab the H, make this pi, resonate to make this neutral, and that makes the major product. Oh my gosh, why is it the major product? Why is that one the major product? Look only at the double bonds in the two products, the pi bonds. More hyperconjugation with 2 carbons attached, less hyperconjugation with only 1 carbon attached. What H needs to be taken to make this other product? Well, it looks like it's a CH2 here. That's this C down here, used to have 3 H's. And we'll just draw an H. Let's see. Just need a little more room. I don't have more room. There's the H. Same arrows. Grab the H, just like we did here, the alpha H. What did you do with the sigma between the alpha H and the carbon? Sigma became pi towards the nitrogen. And how did the nitrogen get neutralized? The pi broke and became a lone pair. And that'll make the minor product. And if you were asked to explain why you circled this product, which, you know, you look at some exams, I often ask that question. Should I put it here, the explanation? Why not? We have a few minutes. Let's even put it in the question. Explain your choice of major product. Sure. There we go. We'll even do it in orange. And here it is. This product has more hyperconjugation for the pi so it forms faster. End of that story. And that's that. We have a little bit more here, apparently. Yeah. And we have that mechanism I didn't do previously. I reconsidered. I'm going to do it. This molecule here is called bromoform. And not really part of my answer, so I'll put it up with the question. And we'll put red first. Try to save a little time here. And this is all about the alpha H times 3, isn't it? Here is the alpha H. Here is hydroxide. Grabbing alpha H. I can't combine that because carbon doesn't already have a lone pair. And if you put a lone pair there, I'm gonna be hard on you. If you say, oh, I created a lone pair, now I'm gonna use it right here. No, you didn't have it there, never was there. You invented a unicorn, you can't get points for unicorns. So you have to draw me the lone pair. You can save yourself a little time, seeing as you're gonna be doing it over and over before this thing changes. And now you've got C anion attached to R, and it attacks the BR, and my BR, I wrote the mechanism over it. So just quickly copy it again. No triangles this time. A little lazy, should show more of that bond. Right in the middle of that bond. I don't know when I'm going to be able to do my shortcut. Maybe only at the end. Hydroxide again. This one's even faster. Inductive effect of Br enhances the acidity of this proton. Attacking with the anion again. It's my hopes you get bored with this mechanism, because when you're bored, that means you know it. And we're ready for a third. Oh, I got 2 BRs on there, sorry. This is the most acidic version we've had so far, so it'll react the fastest with our 3rd mole of hydroxide. And you generate 2 BRs on there. And I'm starting to worry about space a little bit. That's a lame attempt at an anion. I don't like it. Whoa. Ampere minus. We're going to attack our 3rd BR. Wish you could do that on a test, huh? And 3 BRs. So you're well on your way to bromoform, but you have to draw your molecule out this time because the carbonyl is involved in the next step. And you have CBr3 now, which you can write that way. CBr3. And you can't attack an alpha hydroxide. Well, you could, but it won't get you to here. With this excellent leaving group attached, apparently hydroxide's more interested in attacking here than another alpha H over here. And that's what happens. So let's just go with it. When you're stuck, always look at your products and see, oh, there's no more alpha H's being taken off. My next best thing is to attack the carbonyl. And if you look carefully, we're running out of time here. You look carefully in the text, the next step is that thing getting booted off. And you make phenyl once, CH2 once, twice, 3 times. Carbonyl is back with an O bonded to H. And the other product is Br 3 times. And C has the 3 BRs and an anion. Acid base finishes this big mechanism with so much repetition off. And finally, you get those 2 products there. Bromoform is a precipitate here, and the carboxylate is the other product. And that brings to a close today's lecture. So please, by Wednesday, pick questions from tests. Test 1, go to test 1 practice area where you see like 15 exams, previous exams. Pick specific questions from specific tests. Email me. For example, I want to do the spring 18 test 1 part 4 question 3. And I will have that on the screen ready to go. And we'll do review that way. So it goes as, yes, and we have a question.
I'm sorry for interrupting you.
No, it's okay. I was done.
So I have a question about the lab.
Oh, the lab.
Our experiment 3 is due this Thursday, and we have email questions. So I opened the document that say email questions for experiment 3.
Yeah.
And have like student numbers, so we can choose like the different module. Like,
Okay. I'll be assigning student numbers. Hopefully, if I remember today. If I don't remember today, then you remind me later tonight.
sure.
Okay. And yeah, I haven't got to that yet. And I have to post areas for, I think I've finally posted areas for you to submit those assignments, but I haven't given you your student number yet. You are correct. So,
Professor,
yes.
I have a question. It's about the assignment, the assignment that is due on this Friday.
We'll be moving that for 2 days because we moved the test for 2 days. So it'll be a Sunday assignment.
Yeah, and I tried to do it yesterday, and I couldn't find.
The assignment doesn't exist. You can't do it.
No, it doesn't exist.
No, it does not exist. You won't be able to look at it until probably Thursday before I leave. I'm leaving for Atlanta, or Georgia.
So I have another question about the exam. It's gonna be like 6 hours, or it's gonna be just 2 hours?
2
hours.
So you will
like
be cutting those. You'll be cutting those exams by way less than half. And I'll have all the details about this, and it'll actually tell you on the details of the review. Question 1 will be similar to this question on this exam. Question 2 will be similar to this question on this exam. There will be absolutely no surprises about any questions. This
So
I
is the
promise you.
review available now?
No, none of this is available. This is going to take time.
Okay.
But you will know. And yeah, hopefully by Wednesday, a week before your exam, you'll have all the information that you need to know.
And what about the multiple choice? Is it going to be the same?
No, it'll be a lot shorter. There'll be like maybe 5 questions. And I will tell you exactly. Question 1 will be similar to this question, et cetera, et cetera, et cetera. And it won't even use a Scantron. You just fill in the blank.
Okay.
Okay?
Thank you.
So I hope that made people feel a little better. All right? So I will be back and see you on Wednesday. All right, everybody? Okay. Adios.